So the Haber process happens naturally in stellar metamorphosis, and it can also be used as a prerequisite for finding water worlds. I wrote this paper, I forgot to give a talk on it, but basically the Haber process is you have nitrogen and hydrogen from natural gas, you put it through a compressor, and then you have iron catalyst beds that heat up the material, and you get nitrogen, hydrogen, and ammonia out into a cooling tank, and then that cooling tank, it liquefies and you get the ammonia out, and then the unprocessed, the hydrogen and nitrogen that aren't combined, they're reprocessed through the compressor again, and they go through the hot beds of iron again, or whatever catalyst they have there. And basically that process is mimicked inside of Neptune or other late-stage stars. I'll go ahead and read this abstract out to you. Ammonia is found in late-stage stars such as Neptune and Uranus. It is also present in intermediate-age stars such as Jupiter and Saturn. Given the sheer amount of hydrogen and nitrogen available to chemically combine into ammonia, ammonia is 1 nitrogen and 3 hydrogens, it is clear that production of ammonia is a natural process in stellar evolution metamorphosis, and we can mimic this with the Haber process. A naturally occurring Haber process runs counter to the establishment's false worldview that stars cannot cool down enough to form huge amounts of organic and non-organic molecules. We know it happens because we have direct and indirect observational evidence of it happening. What's happening here is in Neptune and Uranus, which are probably around right here on the diagram. They are pre-water worlds. The ammonia is going to build up in their atmospheres, and it's going to take up a larger portion of the higher atmosphere of the star, and as the hydrogen evaporates away, it's going to shrink and lose mass, obviously, and the ammonia is going to build up in the high atmosphere as well as the water that is combining from the hydrogen as well with oxygen. So when we look at these objects through telescopes and we get the spectroscopic data from these objects, we should look for ammonia clouds, because those are going to be sheathing the water worlds. And it was weird that I kind of figured this, and then I looked up on the atmospheric stuff on Wikipedia on Jupiter, Saturn, Uranus, and Neptune, and they have the ammonia clouds above the water clouds, and that's exactly what we're going to see. When we look through the telescopes and we look for water worlds, we shouldn't be looking for water as much as we should ammonia, because ammonia is going to be the dominant molecule in these high atmospheres. And underneath is going to be a very thick ocean world. And I just want to point that out. Even though we're looking for water worlds, it isn't like, oh, we can see water. No, it's not gonna. There's not gonna be a bunch of water. It's gonna be ammonia. It's gonna be different types of molecules. The water is gonna be underneath that area, underneath those thick clouds. As well, the catalysts, and this is the big thing for this theory in general, is that if you have iron entering in the atmosphere of a star, it's going to be burning up. It's going to be an excellent catalyst, and there's lots of iron that comes into the Earth's atmosphere even. And if you have the surface area of Jupiter, Saturn, Neptune, and Uranus, which is much greater than the Earth, of course there's going to be a lot of iron made available for catalytic reactions. It's going to speed up a lot of different reactions. It's going to make a lot of different molecules available, which then can combine and make other types of molecules. And that happens over many, many tens of millions of years. So, in essence, we're not looking at a process where it's just, oh, the star can make all these molecules by itself. No, there are catalysts being made available, and in the interior where the iron is being collected, there are zones where the catalyst is made available to help with these reactions and to make molecules such as ammonia and water. But anyways, I thought I'd make this Haber process. I looked up on all my videos. I haven't mentioned it anywhere, but it's a relatively new paper, July 22nd. But there are processes that we have mimicked an industry that stars do on vast scales naturally. And that being said, there's probably other industrial processes making other types of molecules that nature does without any of our help. And just drawing the conclusions from what we have figured out and then applying them to, well, shit, every single object we see in the galaxy. Well, it's pretty obvious to draw the conclusions. Anyways, I'll link this to the bottom of the page. This, of course, this can be much more advanced than what I mentioned here, but the basics of it are outlined, and I have some pictures for you guys. All right, later.